First time meeting oh. I never figured it out to you last year. That's it? Very surprised. Good job, buddy. Thank you. Anyway, I tell the shows me that so say just take it. Okay, yes, and I anyway,
All right, so we're gonna talk about a couple questions. A lot of time some of you guys just spend some time to work on your homework instead of talk about other things. But because you will save yourself a lot of time. Actually, uh, so I found like smart students usually finish stuff early. They just like they have all the time to finish other stuff. Yes.
I have a question about yesterday's homework, not this yesterday's homework.
I didn't have homework yesterday.
No, like 2 days ago.
About what?
It's one of the trade. I was wondering if you go over.
Give me a second. Let me finish this stuff. Okay, so squeeze theorem. So one of the things that you have to understand of squeeze theorem is like, do you remember this function? Do you remember the graph of this function look like?
Yeah, like oscillating.
It was oscillating. It was like so it was going to here, but it's oscillating between which two value? Negative 1 to 1. So it was going like this, and it was like this, and it was oscillating really fast, and it was like something like this, and then this is a sine of 1 over x graph. Now it's only oscillating between 1 and negative 1. But today we are interested in something else. We're interested is what if you have say, hey, what's limit x equals 0 of x of sine of 1 over x? Now this one obviously different looking than the other one because we have additional x that's in the front. Now, do you guys know what does x sine of 1 over x graph look like? Probably don't remember, right? So then how do I approach 0? Because this is not sine x over x. This is sine of 1 over x times x. Because sine of x over x, that's you reach 1. And that's very easy because that's just simple trig limits. However, this one's a little bit different, right? And you say, well, how do I find out the answer for limit x equals 0? If I go with originally thought process, it's probably going to be oscillating or be like does not exist. But this one's slightly different. So this one, in order to evaluate this one, it's going to have to think about a little bit further. So you know it's x times sine over x. Let's break them apart. Let's break them this part and this part, right? So, and let's just look at sine of 1 over x. We know according to the graph on the right, on the left, is sine of 1 over x is oscillating between negative 1 to 1. And I'm really close to the other function. I'm really close to limit x equals 0 x sine of 1 over x. So you say, okay, well, what if I can make this look like this? How would I do that? Times x. Yeah, so just take this and times the whole inequality by x. So it'd be negative x less than sine of 1 over x and less than x. And since the question is asking, what is limits x approach to 0 of x sine of 1 over x? Is the question mark? And we say we don't know. But what we can do is we go to the bound. We're going to go to the upper bound and the lower bound. We say, hey, let's treat it this way. Let's take care of the limits as x approach to 0 of negative x. What does that equal to? 0. Limit x approach 0 of x is equal to 0. So therefore, because this squeeze theorem says as limit x approach 0 of x sine of 1 over x must also equal to 0 because the upper bound of this is equal to 0 and the lower bound is equal to 0. And then we say, well, yeah, that's it. And that's simple as that. Now we're going to go to here. We says, we'll show you the graph. So in case you don't know, we're going to show you a x and negative x and the x. And we also show you the sine of 1 over x. And this is the graph. Now, is it that's not the graph we're interested in. We're interested in the x sine of x. So I'm going to put x in front of it. And boom. So we talked about this last year. It's oscillating between -1 to 1. So even though it's oscillation, but it's converged this time as opposed to diverge. Because it's bounded by the x. Because see the x graph is the blue graph, right? This one, and it's bounded by this one. So it's bounded by two graphs. And the other one is going to go to 0. This one's also going to 0. So therefore it's equal to 0. Does that make sense? Now, what if I create a question? Says, hey, what is limit x approach 0 of sine x over x? Slightly different than before. No, actually not 0. I'm so sorry. I made a mistake. So it's approaching infinity. It's approaching infinity. Now, I cannot just say you told me a number. I have to show me the work, how you get it. So this is the things not on the homework. This is also on the test. But it's not reaching 0, it's reaching infinite. Once you got the answer, once you see how to get there, I want you to look at the graph on decimals. Now, if you look at this one, a little bit different, right? We know sine of x. So you start with what we know. It's oscillating between 1 and -1. And in order to make that function like that, I multiply by what? Not x. 1 over x. Right? Now, since I don't know what's in the middle, I can look at the boundary. I look at the boundary, says, okay, well, limits x approach to -1 over x. to infinity is equal to what? 1 over infinity is what? 1 over a really large number, right? That's negative 1 over x. Limit x approach infinity of 1 over x, that's also equal to 0. So you'd say limits as x approach 0 of sine of x over x of infinity is equal to 0 as well, because due to squeeze theorem. Now, if due to squeeze theorem, then you say, okay, what does a function look like? Well, it looks like this. It looks like this. Now, I'm not looking at reach 0, so I'm not looking at the center. I'm looking at all the way to infinite. And this is bouncing between the 1 over x and x. Do you see that it bounces in the structural way? But since the top line and the bottom line is going towards 0, the middle line is sandwiched into the middle. And so it has to go to 0. Yes?
Good way to find limit using that, like, type something.
Probably only look at the graph. I don't think there's a way to do it. It might be. I don't know. I don't know how to use the whole function of all the things about this, but I don't think so.
Yeah.
But I could be wrong. But you can see it from graph, because you can analyze in graph. You can figure out it was bouncing between two lines, and not only that, it's just really structured the bounce between 1 over x and negative 1 over x graph. And for me, it's like a very pure satisfaction of how math actually works. Like, how do they come up with the certain things? And it's actually very interesting. Okay. So we also forgot to cover something, which is also something very important, is I'm going to talk about vertical asymptote. The whole and the horizontal asymptote. Now, this is also on the test, but it's not on the worksheet. Okay, it's on the test, but not on the worksheet. So vertical asymptote has a name, a calculus name. We're going to call that as non-removable discontinuity. Non-removable discontinuity, because on the test, I'm going to ask you to find non-removable discontinuity. Whole is also called removable discontinuity. And the horizontal asymptote is actually limits as x approach to infinite. Is x approach infinite of f of x equal to L. And also limits x approach to negative infinity of f of x is equal to another L. Now, for the non-removable discontinuity is after cancel factor, especially after cancel factor, it has to be after the denominator equal to 0. So denominator equal to 0. And that's how you find the vertical asymptote. Removable discontinuity is the cancel factor equal to 0. So I want you to find everything here. What will be the x squared minus x minus 6 over x squared minus 4? What will be all three things here? What will be all the three things here? Did you find all three things? The remote discontinuity, I need you to tell me the location of that remote discontinuity. Like this is an x coordinate and y coordinate. Yeah. So this is also going to be on the test, but it's not on the worksheet. All right, so usually I'll factor everything. So that's going to be x plus 2 and x minus 3 over x plus 2 and x minus 3, or x minus 2. So if I cancel this, the cancel factor is going to be x plus 2 equal to 0, x equal to -2. Plug it back in. So f of -2 is equal to -2 minus 3, -2 minus 2. That's equal to -5 over -4. So it's equal to 5 over 4. So be remove discontinuity located at this, right? And that's going to be remove discontinuity. Now, some people, they say vertical asymptote is +2 and -2. It's not true because one of them is a whole, the other one's not. So that's why you always do a factor first. If you do factor, you can get rid of that whole first. And then non-removed discontinuity is going to be the vertical asymptote. Then it would be x minus 2 is equal to 0, x is equal to 2. And then that will be a 2 thing. Now, if I want to find horizontal asymptote, it's going to be when limits x approach infinity and negative infinity of x squared minus x minus 6 over x squared minus 4. Now, some people say it's on the pre-calc, you just look at the degrees. Is the top heavy or the bottom heavy? But in calculus, slightly different. So in calculus, what do you have to do? Divided by what? Highest degree of the numerator or the denominator? Numerator or denominator?
What?
Divided by highest degree of the numerator or denominator?
Numerator divided by
what?
What?
Highest degree of the numerator's highest degree or the
Denominator.
It's a denominator.
Yeah.
Good. So it's denominator. I'm trying to trick you. So you're supposed to divide it by highest degree of denominator, right? So I can write it down here. Usually, now this I say usually divided by the highest degree of the denominator. Now, not numerator. So in this case, this will give you a simplified version of this. So be 1 minus 1 over x minus 6 over x squared. So I need to see that work of you divided by highest degree of denominator. So 1 minus 4 over x squared. Limit has been to be very, very important section. Bennett, what are you doing with that phone? Okay, so this will go into 0. This is going to go 0. This is going to 0. And in this case, it will go to 1. In other cases, don't have to be. Now, if if you have, let's say, limit x approach infinity of x over x squared minus 2x minus 1, 3x plus 2, you divide by highest degree of denominator. In this case, will be here, x squared, x squared, x squared, x squared, x squared, right? And if that's the case, that's going to be 3 over x plus 2 over x squared over 1 minus 2 over x minus 1 over x. If you have x approaching infinity, this will equal to 0. Because this is equal to 0, this is equal to 0. The top part is equal to 0, bottom is equal to 1. So it'd be 0 over 1 as horizontal asymptote is at 0. Now, what's maximum horizontal asymptote you can have? Y2. Okay, just imagine, it's fair. The maximum horizontal asymptote you can have 2. You can have infinite amount of vertical asymptote, but horizontal asymptote can have 2. Because you have to look at the two perspectives. One's going to infinite and one's going to negative infinity.
Yeah.
So what will be a horizontal asymptote in the following 3 different cases? So I say find horizontal asymptote. Find horizontal asymptote of this case. First one is going to be 5x minus 3 over square root of 9x squared minus 10. Okay, so I want to say, can you find horizontal asymptote in this case? Now, all those things that I'm going over right now is not on the worksheet, but it's on the test. If you're done, look at the graph. What's the horizontal asymptote in this case? 5 over 3? Yeah. That's wrong. Look at the graph. See how many horizontal asymptotes there are. Oh, There's 2.
Is it plus or minus 5?
Well, first of all, you have a limits x approach to infinity of 5x minus 3 over root of 9x squared minus 10. And then if I says, okay, well, I'm going to copy this exact same thing and I paste here. Limit x approach to infinity. Now, I'm going to divide it by x here, but the highest degree of denominator is actually x. But the problem is inside x squared is actually x. Inside square root is x squared, because square root x squared is absolute value of x. Does that make sense? But that's going to give you a limits as x approach infinity of 5 minus 3 over x over 9 minus 10 over x squared. And if that's the case, it's going to be 5 over root 9, which is 5 over 3. The problem is when you limit x approaching negative infinity, that's going to be 5 minus 3 over x, square root of 9x squared minus 10. If it's an absolute value of x, it's a piecewise function, right? On the right is the x. On the left is the negative x. Does that make sense? So right here, it's going to be negative root x squared. Which is, that's equal to 5 over 9, or 5 over 3, negative. So they are 2. And if you look at this graph, I don't know what's a function. Can you guys remember what function is?
5x minus 3.
Over what?
Over square root of 9x squared minus
Minus 3?
minus 10.
If you see that there's 5 y equal to 5 over 3, and there's a y equal to negative 5 over 3, right? If we go to infinity and negative infinity, it's going to get 2 asymptote. Remember we were talking about horizontal asymptote? It's like you are not sure. Kind of like Joshua right now. It's like a boyfriend, girlfriend. He's debating. So they cross in the middle, but we don't care about the middle. We care about what happened eventually. Eventually to the right or eventually to the left. Are we okay here? Now, there are a few other cases that is a little bit interesting that I put on the last year's test, if you remember. One is like something like find horizontal and vertical asymptote of each. So the first case, I get 2x over x minus 1, absolute value. Right? That was the first case. The second case, I give you that it's the radical case, which is f of x, which is we just talked about it. So it's like 3x over root 4x squared minus 4. The last case, which is I'm really like want you to know, is this case. Do you remember this case? Huh? You don't divide by e to the x on this particular one because this one's the real one. Well, no. Thank you. No. No, you're gonna be grouped with you're gonna be grouped with huh? No. Luke, you can switch sheet with Venom. You and Luke is gonna because there was two fours there, and there was only 1 5. So now if I switch over, then wait, then that won't be fair either. Hold on a second. Another thing. There's 2 5s here. A lot of group with 5s, but that group has 2 4s. That group has 2 4s.
It's probably the easiest.
Look, switch you Ben. So now we're 2-5, and right lane can be in that group. You and Bennett switch C. Yeah. But we switch next time. Don't switch now. You switch next time. Bennett. Next time you and Luke is gonna switch C and the right hand's gonna join that group. So there was two 5s and 2 4s. Huh? You like your group? What?
Stop trying to fucking sabotage me. He's I know about anything. Shut up. We all want it. We all want your army.
I like my
You don't like Bennett? Are you racist to white people?
No, side
Makes sense. I like when I say I don't get enough.
You don't get enough stuff like in the marching band.
Well, I'm in front of
Huh?
I'm inside.
Oh, you're inside?
Yeah.
Okay. You're not in marching band? Who is that?
Like little. Yeah.
So you don't have to be in the marching?
Yeah.
Huh?
I don't watch.
You don't march at all?
Sure.
No, we're so.
Okay, find vertical asymptote and horizontal asymptote.
I'm an American person. That's not I think we tried it.
I mean, it's fine, but you do have a 2 horizontal asymptote on that one. But you might not have vertical. You might not have vertical Yeah, whoopies.
Only one.
I guess most people I think that's my name. I know you did not want it. I wash my hand with it. No, I just
I have 2 days to do it.
No, I have 1 day.
Oh.
Is it today?
Oh. You bet. Oh, no, I'm not saying. Yeah. Except that
Pretty easily.
no, it's still not. As long as I hear so then you'll make zero. Okay, you have to do it both sides.